So we're going to do a quick example of using matrices and inverse matrices to solve a system of equations. So this one actually comes from your homework. It's number 5 if you're following along with that homework. Otherwise, it's just an example to do. So like whenever we're given a system of equations like I have here, the first step in doing the system as a matrix is to rewrite the system as a matrix. And the first thing I'd ask us to look at, I just kind of Googled a random little like system of equations courtesy of coolmath.com, and what I wanted us to see, like if we were using the elimination method, like if this was our system here, whenever we do the elimination method, we just kind of look at some of these examples. The x's and the y's are just along for the ride. They're just labels that help us know what we can combine with what. In other words, they're just placeholders. So in that light, when we're doing a system, the x and the y don't really matter in regards to like the actual numbers we're using. They're just placeholders and labels. So the first step in our writing our system as a matrix is essentially just getting rid of the x and the y. So I have the matrix already prepared below it. So I'm just kind of showing you how they line up on top of each other. So like if I just slide the original equation away, the first matrix would just be the coefficients. Notice how they go linear. Now the next thing is we need to introduce some variables. So I already have that matrix prepared, and we're going to put the variables in vertical fashion in order that they're read. So like see how this was first and this was second. That's why I listed that x first and this second. And we know here that when we're doing multiplication, we would simply take, we would take this row and multiply it by this column. So like the 5 would get multiplied by the x, and the -2 would get multiplied by the y. And it's nice just to check that multiplication, which I also prepared. We can see that if I multiplied those back together, I get the coefficients as they're supposed to be. The 3 is in front of the x here, the 7 should be positive in front of the y. So that multiplication will work. So we have our coefficients in one matrix, our variables in the next one, and then we obviously need it to be equal to something, and we know that when matrix multiply, like a 2 by 2 matrix, multiplying by a 2 by 1 matrix should form a 2 by 1 matrix. So we set it equal to the answers, and the answer matrix, you can see, again, just follows the order of the equations from top to bottom. So we first have to represent it as a matrix equation. And if we're going to use inverses, what we're saying here is that, and let's just kind of put some labels here first. Let's call this matrix A, we'll call this matrix X, and we'll call this matrix B. Well, what I know is that if I took the inverse of A and I multiplied it by A, that would give me the identity matrix. So if I started with matrix A times X was equal to matrix B, if I multiplied matrix A on the left by the inverse of A, I'd have to multiply matrix B on the left by the inverse of A. And again, just remembering that the order of matrix multiplication is not commutative, so the order I did over here, I need to make sure to follow the order over here. So I know that this would just combine to the identity matrix, and then over here again I would have the inverse of A times B. But I know that the identity times any matrix like X would just be that matrix X. So what I can say here is if matrix X was holding my answers, I'd be able to find my answers by simply multiplying the inverse of A times that matrix B. So I've already have that prepared in my calculator. I've already entered matrix A and matrix B into my calculator. So again, I just went to second matrix, and then we can see that matrix A has already been entered as the coefficients, and then matrix B I've also entered as the answers here. So I'm just verifying that they're in my calculator. You could take a moment to do that. But again, to get the answer, what I need to do is I need to take the inverse of A. So I can recall matrix A, and I'd want to use its inverse. And I would just simply multiply that by matrix B, which contained our answers. And again, I called that matrix B. So a matrix times a matrix should give me another matrix. So that matrix, which I'm just going to slide over here now, we said that this matrix was equal to X. So matrix X, I'm just going to rewrite with its elements again, X and Y. And we said that was equal to this matrix, -4 and 2. So we know that elements in corresponding spots are the same. So like if I use a highlighter here, we know that whatever is listed first row, first column, My computer's kind of frozen here. But first row, first column, so x is equal to -4 and y is equal to 2. So if we needed to, just because my Smart Notes is being weird, I could write that as the ordered pair, right? We know that the answer, oh, there it comes back. X was listed first, so x is -4 and y is 2. So we'd write our answer as an ordered pair because we're solving a system of equations in two variables, which we know is just modeling where these two lines intersect.